In today's lesson, we are going to be looking at the cosine law. So we've already looked at sine law, but now we're going to learn a different trig law, which is the cosine law. So, based on what we know, let's see if we can solve the following triangle. Well, first of all, we might want to do a check. Is it a right angle triangle? I don't see any right angle indicated, so I don't want to assume anything. So because we don't see one indicated, we're going to say that no, this is not a right angle triangle. So then we move on to our sine law. Do I have a full pair and a half pair? Well, if I draw out my pairs, I can see I have half a pair here, I have half a pair here. I'll use different colors. So half a pair here, and half a pair here. So I don't have a full pair that I can use to help me use sine law. So there needs to be some other law to use that will help me find some missing information, or to help me calculate the missing information. And that's where the cosine law comes into play. So this one we can't solve with what we know yet. So we can't solve this with what we know yet, but we are going to learn how we can do that. And that's where the cosine law comes into play. So the cosine law, there's two different formulas. So this is going to be a little bit more complicated than the sine law because it's different all the time, or not all the time, but it's a different calculation, and we have to be careful of where we plug things in. With the sine law, we weren't too worried about that, all right, because we could put parts on the top or on the bottom, it didn't really matter. But for the cosine law, we do have to be very specific of what we put, and it's not quite as easy as saying the side and its corresponding angle. It's a little bit more complicated than that. The one thing that is relatively straightforward is what we're looking for. So if we're trying to solve for a missing side, we are given SAS, or side angle side. You might also think of this as a sandwiched angle, because our angle here is sandwiched between two sides, and we're missing the third side. If we're trying to solve for an angle, we're given all three sides, or SSS. So that means we'd be given all three sides, and we can use that to help us find any given angle in our triangle. Now there are different ways that we could write it out, but the main thing is what we're focusing on. So there's a couple of key things in our equation that need to pair up. So if I'm solving for side A, B and C don't really matter, there are other sides. We need to make sure though that the angle, or cosine A, is the pair of the side we're looking for. So if we're looking for side B, we have to make sure that we have angle B. If we're looking for side C, we have to make sure we have angle C. So that's one of the things that needs to be paired up. When we're looking for solving an angle, again, cosine of an angle, we need to make sure that in our formula, the side that we're subtracting is the pair for that angle. Right? So it's key that we make sure we pair those up. Right? The other two parts, B and C, don't really matter. It doesn't matter which one goes where. But for the A's, or for the angle that we're finding, or the side that we're looking for, it's really important that they pair up, as we can see here. And again, we'll go through some examples with that. So we want to solve the following triangle. So if I'm looking at this triangle, right, again, I could go through those steps. Is it a right angle? No. Do I have a full pair anywhere? No. Now I'm going to look, so I know I can't be right angle trig or sine law. Do I have enough information for cosine law? Well, I see I have a side, I have an angle, I have a side. So I do have enough information to find this missing side over here, or little a. So I'm going to use my formula to help find that side. So really doesn't matter what formula we use, going back to that previous page. as long as, again, the side that we're solving for is across from or paired with the angle that we have. So because we do have the angle across from this missing side, we have enough information to plug in. Again, it doesn't really matter what I label. I could say this is b squared equals a squared plus c squared minus 2ac cosine b. It really doesn't matter, again, as long as we pair this up with this. Those have to be the correct values. So I'm going to start plugging in my information. A squared is going to stay the same. B squared is 12, so 12 squared plus c squared, which is opposite of angle C, or 16 squared minus 2 times 12 times 16, then finally times cosine of the angle, or 135. One thing to remember, make sure we multiply by cosine of the angle at the end for the second part. For whatever reason, I find that students do forget to multiply by that cosine of the angle. Whatever the reason is, they just seem to forget that. I'm going to go through and I'm going to solve it in parts because it does tend to be a little bit easier that way. So I'm going to do the 12 squared plus 16 squared. I get 400 minus 2 times 12 times 16 times cosine 135, and I get negative 271.53. I'm going to then calculate this, so 400 minus negative 271.53, or 400 plus 271.53. It's 671.53. The last step, I need to square root both sides to cancel out that squared. Oops. So now I get A is equal to 25.9. So that is my missing side length. I now know that side A is 25.9. Let me leave that as A, and I'll use 25.9. Now what I need to do is I need to find a missing angle. Because again, solving the triangle means to find all missing parts. So I need to find all the missing parts. So I'm missing two angles. I just really need to use cosine law to find one. I could, if I wanted to, use my sine law because I do have now a full pair, and regardless of which angle I look for, half a pair. So I could use sine law, but because we want to really practice cosine law, we're going to stick to that. And let's look for angle B. So we're going to do cosine B is equal to a squared plus c squared minus b squared, all divided by 2ac. So again, the main thing is that this is paired up with this. So the angle that we're looking for, the side pair of it goes into the subtracted term. So cosine B, we don't know, is equal to a squared plus c squared minus b squared. So we have 25.9 squared plus 16 squared minus 12 squared, all divided by 2 times 25.9 times 16. And again, I'm going to go through and solve it in parts. I'm going to simplify the top first. 25.9 squared plus 16 squared minus 12 squared. Get 782.81 divided by 2 times 25.9 times 16. 828.8 squared. Now, this is very similar to our cosine ratio. When we're solving for an angle, and we saw this with the sine law, anytime we're solving for an angle, we have to do the inverse function. So inverse of cosine, or cos -1, of that fraction, 782.1 divided by 828.8. Again, if you really want to, you can figure out what that decimal is first. I'm avoiding rounding right now, just to make it a little bit more accurate. But what we should get roughly is inverse cosine of 0.94, roughly, and then we find that our missing angle, or angle B anyways, is 19.95. So angle B is 19.95. So that's finding a missing angle using the cosine law. Now, if I want to find my other missing angle, angle C, I could go through and do a cosine law again. However, it's really quite straightforward now, because I can do 180 minus 135 minus 19.95 and get that missing angle of 25.05 degrees. So very similar to sine law, when we're trying to find, or you solve the following triangle, there is a point where when we're finding our angles, we really only need to find one, or assuming that we're given one, we need to find one, and then we can use the idea of all angles adding up to 180 in a triangle to find the missing one. So really you only have to use the law twice, or a law twice. And we've solved the following triangle because we have information now for every single side. So let's take a look at some word problems, just again to get an idea of going through these same questions and trying to place the information on a diagram. So, in our first example, to determine the length of a small lake, a surveyor takes measurements. From a point C, the distances to point A and B at the ends of the lake are 854 meters and 788 meters. The angle between the lines of sight to the 2 points is 107 degrees. Determine the length of the lake. So, we have, say, points A, B. Our camera person is point C. We know then the distances between the two ends, 854, 788. The angle between the 2 points is 107 degrees. And we want to know what is little c, or what is this distance across the lake. Well, because I'm solving for a missing side, again, we could go through the steps of, is it a right angle triangle? Can we use sine law? And then if not, it must be cosine law. In this case, it is cosine law because, again, we have a side, angle, side. We have a sandwiched angle. So we can use cosine law here to find that missing side. So I'm going to take my formula, c squared equals b squared plus a squared minus 2ba times cosine c. Again, doesn't really matter how you write it out. Just make sure that the angle, or the side that you're looking for, you have that angle paired up. The other two sides don't really matter. And really in this case, it's not too difficult to mess up because we only really have one angle and we only have two sides, and it doesn't matter where those two sides go in terms of B and A. It's more when we're trying to find the angle that it's really important we put things in the proper spot. So So c squared, we're going to leave c squared equals 854 squared plus 788 squared minus 2 times 854 times 788 times cosine of 107. Again, I'm going to go through and solve this in parts. I'm going to solve everything before the subtraction and everything after the subtraction. So 854 squared plus 788 squared, we get 135,000. Oh no, 1,350,000 and 260 minus, so 2 times 854 times 788 times cosine 107, we get negative 393,504.25. Add them all together. 1,350,000, 206 minus we just found, we should get 1,743,764.25. Now, to get c by itself, we need to take the square root of this answer. That will cancel out the squared. We get c equals 1,320.52. So let's just do a quick double check just to make sure. 2 times 854 times. So we have the length of the lake now between our 2 points. So we know the length of the lake using cosine law. So therefore the lake is 1,320 meters long, roughly, or 1,320.52 meters long. Looking at one more question, this time we're going to be looking for an angle. So an ice pilot leaves Whitehorse and flies supplies into Dawson City, a distance of 120 kilometers. He continues on to Old Crow, a distance of 140 kilometers. Finally, he returns to his home base of Whitehorse, a distance of 210 kilometers. At what angle were the first 2 legs of his journey to each other? So, if we want to draw this out, we have a little map of Yukon Territory here. So he starts at Whitehorse and flies to Dawson City. This might be a little hard to see it, but he starts and does this trip. He then goes from Dawson City to Old Crow, and then from Old Crow he goes back home. It's a small triangle, so a little difficult. There we go. So we want to know at what angle were the first 2 legs of his journey to each other. So essentially what we're looking for is, what is this angle here? And we have some information that we can put down. So we know that the distance from Whitehorse to Dawson City is 120. From Dawson City to Old Crow is 140. And from Old Crow to Whitehorse, it's 210. So we have enough information to find our missing angle because we have side, side, side. We have all 3 sides. So if we have all 3 sides, that should indicate to us, or hopefully it will start to indicate to us, that we have enough information to find a missing angle. And again, this is where it's important that we label our points, or that we plug in our points into the formula correctly so that we pair up the angle and the side. So what I mean by that, again, if we just write down one of our formulas, a squared, or sorry, not a squared, cosine A is equal to 2b squared plus c squared minus a squared divided by 2bc. We want to make sure that the angle we're looking for and its side pair are put in correctly. So if I'm looking for A, we can call this A here, this angle, then side A is across from it. B and C doesn't really matter. We can say old crow is C, white horse is B. So that means that 140 is little b and 120 is little c, right? The sides opposite, or the side that's paired with those angles. But the main one we're concerned about are the angle that we're looking for, A, and what its side is to make sure we put it in the correct spot. So cosine A is equal to 140 squared plus 120 squared minus 210 squared, all divided by 2 times 140 times 120. Again, I'm going to simplify the top first, and then the bottom. So 140 squared plus 120 squared minus 210 squared. Negative 10100. And 2 times 140 times 120. We get 33,600. To get A by itself, I move the cosine over. It becomes cosine negative 1. That fraction, if I divide it, essentially becomes negative 0.3. And then A so again, just double checking. Yep, negative 0.03. And then when we do the inverse cosine of that, we get that the angle is 107.45 degrees. So then we know that the angle between the first two legs is 107.45 degrees. So again, the key thing with the cosine law when finding the angle is that the angle you're looking for and its corresponding side are paired up correctly. You understand what those two are so that they go into the formulas in the correct spots. But again, it's used for obtuse or for non-right angle triangles. Cosine law is specific. There's two specific kind of criteria, either that sandwiched angle or all three sides. If you don't have those, then chances are you have to use sine law. And if you don't even have enough information for sine law, then there's just not enough information. But again, just make sure you label everything clearly in your triangle so that you're clear about where your information goes.